Okay, this is 2011 Exam 1 Question 7. There's a couple of ways to approach this. One is using Newton's third law, the other is using Newton's second law. So we'll try Newton's third law first. So we want to know what the force by block C on block B is. So it's really this force that we're interested in. That's block C on block B. Well, there's an equal and opposite reaction force, which is block B on block C. This is from Newton's third law. So Newton's third law tells us that the force of block C on block B is equal and opposite to B on C. Of course, all the forces from block B and block C are basically weight forces, and it's the weight of these two blocks acting on block C. So it's really just mg. But the m is 0.05, that's block A and block B. Those two together give us 1.5 newtons. So the force by block C and block B is 1.5 newtons. But you can look at this using Newton's second law as well. So I'll just draw these blocks again. And Newton's second law, so the net forces, and we'll choose block B. So the net forces on B. If you'll have a look at block B, one force on block B is the weight force. Then there's another force on block B, which is the weight force of, I'll just call that block B, the weight force from block A, and there's the reaction or contact force from block C. I'll call that FC on B. So all these three forces are on block B. But the net force on B, because it's just sitting there, is 0. And the net forces are, we've got the reaction force minus the weight force minus the other weight force, and that all equals 0. So really, the force of block C on B, the normal force, are the two weight forces, which are 0.05 times 10 plus 0.1 times 10, which also gives us 1.5 newtons, just like we got before. So there's really two approaches, a Newton's third law or Newton's second law gives us the same result.